All right, this is the review for the final. Now, I don't have enough time to do every single question, so I only chose the ones that are going to be covered on the test. So we're going to start out with question number 3. It says, how would the graph of the function y equal x squared be affected if it was changed to y equals 2x squared? So all we have to do is graph both of them, look at the picture, and figure it out. Y equals x squared, and y equals 2x squared. All right, now this is x squared, and this is 2x squared. It got skinnier. Another word for that would be getting narrow. It became narrower, or it was stretched. The function y equals x squared minus 5 is formed by shifting the function y equals x squared plus 2. This is the one that was shifted. Since this is the one that was shifted, this is the one that we have to graph first. So we're going to graph y equals x squared plus 2. And then we're going to graph x squared minus 5. All right, we start off over here, and we end up coming down there, which means it went downwards. 1, 2, 3, 4, 5, 6, 7. It went down 7 units. All right, the function y equals negative x squared plus 3 is created by shifting. So we shifted this one, which means we start with this one first. Negative x squared minus 1. And then negative x squared plus 3. All right, negative x squared plus 3. All right, here's the graph. We start off right there, and then it moves up. And it moves up 1, 2, 3, 4 spots. So we'll say up 4 units. All right, portion of the graph y equals x squared plus minus 4 is shown below. What point will the graph cross the x-axis again? That's actually pretty easy. Since this is going to be the vertex, then this is the axis of symmetry, which means all these dots are equal distance apart from each other. So this is 1 spot away. The next one is going to be right here. This is 2 units away. So it's going to be 1, 2 over here. And this one is 1, 2, 3, 1, 2, 3. Now that we have them equidistant from each other, now we can go ahead and answer these questions. When would it touch the x-axis again? It looks like it's going to touch it at 2, 0, right here. And what is the point of symmetric to negative 3, 5? This is negative 3, 5. Looks like positive 3, 5. Number 7 says one graph will function will appear to be shifted 3 units up from here. Now we have f of x, which is the same thing as y. Y equals 2x squared minus 4. If we're going to shift it 3 units, we're going to use 3 units. But it says up, which means we're going to add 3 units. That ends up giving us y equals 2x squared minus 4. Also, you could have just graphed that. I'm sorry, minus 1. You could have also just graphed that and just looked at the picture and realized it was going to touch at negative 1. The table corresponds to the following equations. Now it says, what is the vertex of y3? So what we're going to do is we're going to take y3 and graph it. All right, once we graph it, go ahead and take a look at the picture, or we can go ahead and take a look at the table. Here's the picture. There's the vertex, 0, 0. Or go to the table. And as you can tell, these are the same, these are the same, these are the same, which means this is going to be our vertex. The axis of symmetry y equals 3. Again, the axis of symmetry cuts it in half. So what we can do is we can take a look at the picture, the graph. And we can see where can I draw a vertical line that will cut this in half, and that'll be right there. That crosses the x-axis at 0. So the axis of symmetry will be x equals 0. By the way, axis is an x. Now they ask some questions about WOD2. For those, we can also just graph this and look at the answers, or we could use the table right there. Let's check out the table. Y2 is right here, and here's the x value, so we're only going to be looking at those two columns. And we're looking for the vertex. Since all these are the same, these are all symmetric pairs, the vertex is going to be 0, 5. The axis of symmetry will just be the x value of the vertex. The x value will be this one right here, so we call that x equals to 0. What is the symmetric point to 1, 6? We've already connected it. Here's 1, 6. If you follow the line, it's negative 1, 6. So you could either do it using a table like I just did, or using the calculator like I did. Just choose the one that's best for you. Candace has 60 feet of fencing that she will use to make a rectangular pen for her dog. The graph below shows the area of the pen as a function of the width of the pen. Okay, there's your equation. They ask us a question. It says the maximum area is, well, this is the width. So they didn't ask them for the width, they asked for the area, so I'm not going to use any of these numbers. Here's the area. It's on top, so I'm going to use this area. Okay, so we're going to keep looking until we find the largest number that's being used. And in this case, it's 225. Now, for this time, they're going to be asking about something else. They said well, the width. We're looking for the width. So the numbers are going to be coming from down here. The answers are down there. When the area is 200. Now, the area is 200. And if you draw a horizontal line, you'd realize that it touches it 2 times. So we're going to have 2 answers. The first one is 10. The second one is 25. My lines might not be straight. It might be a different number, so just make your straight lines and you figure out if the answer is wrong. The vertex is right here. Again, we're going to have to approximate. Looks like the vertex is between 2 numbers. Vertex looks like it's between 15 and 20, so let's just say that's 17 to 25. What is the domain of the situation? Again, every time you look for the domain and range, you want to try to draw a box around your picture. And wherever the dimensions of the box touch, that's your answer. Domain is your x value. X starts at 0, goes to 30. The range is the y value, starts off at 0, goes to 225. The last question for this one says, which of the following statements is true based on the graph? It says, to get the maximum area, the width and pin should be 25. That's not the maximum area. The maximum area possible is 200 square feet. That's not the maximum part of the graph either. As the width increases, the area increases. For this case, it's true. I'm increasing both ways. But after I get halfway, I start decreasing. This is incorrect. To get the maximum area, the width should be 15 feet. Let's see. Oh, that is correct. 15 feet. All right, use the graph to answer the following question. Ask what is the axis of symmetry. Again, axis is going to be an x equal to, and an x cuts. So this is going to be cut in half right there, where x crosses -2. The vertex is right there. That's at -2, 4. The y-intercept is where the blue line touches the y-axis. This is the y-axis. It's being touched right there. And the symmetric pair, 4, -5. Well, first let's locate 4, -5. Symmetric pair is the dot that's right across from it. And that looks like -8. I'm sorry. Yeah, -8, -5. Use the graph to write for the questions and ask for the domain and range. Again, for domain and range, all you got to do is draw a box around it. And for the domain, we're looking for the x. And it looks like -2 to 4. For the range, we're looking at the y. Looks like -1 to -9. Again, the vertex is the uppermost or the lowestmost dot. In this case, is right there, point, and that's 2, -1. And the axis of symmetry, again, that's an x. It's the x value of the vertex. X equals to 2. 2 points on the graph of quadratic function are shown on the grid below. So what they're asking for is what is the axis of symmetry. So again, remember, if these are symmetric points, they're the equal distance away from each other. So let's see. So this is the middle point right here. So if I'm drawing axis of symmetry, I'll cross right there an x value of 1. So all I did is count the notches and found the middle point, and that's what I do with the axis of symmetry, because the axis of symmetry always cuts it in half. What would the vertex be for each problem? Again, this is y equals x minus h plus k. So this right here, h comma k, would actually be the answer, but this is negative, so you have to change the sign. So if this is -4, this is +4, comma 7. The vertex is 4, 7. Now, if you're not really sure about this, or you might think you might forget about the negative sign and all that, just graph it. It says x minus 4 squared plus 7. Now, as you can tell, the vertex is right there. That's 4, +7. That's how you can find it a little easier. 34, as for the area, obviously this is a square, so this is x plus 2, this is x plus 2, x plus 2, x plus 2. If I want the perimeter, I just add them all together. These x's need a number, so I'll pop a 1 right there. Once I add them all together, this is 4x plus 8. As for the area, you got to multiply length times width. And if you multiply these, you're going to have to use the box method. X plus 2 times x plus 2 gives me x squared, 2x, 2x, and 4. These two add together. I end up with x squared plus 4x plus 4. Now let's take a look at the next one. All right, they also want the perimeter. So in the perimeter, you add all 4 sides. So we're going to go ahead and write down all 4 sides right next to each other and just add them. Since this is a rectangle, the width and the length are the same on both sides. This gives me 4, and this gives me 10. So the perimeter is 10x plus 4. As for the area, you're going to have to multiply them together. And when you multiply two equations, what you're going to have to do is use the box method. 2x7, 3x minus 5. This gives me 6x squared plus 21x minus 10x minus 35. These two add. Final answer is 6x squared plus 11x minus 35. For this one right here, they want just the shaded region. This is region right here. This is really simple. You find the area of the large rectangle and subtract it from the area of the small rectangle. All right, the large area, you're going to have to multiply these two things together. That's 2x times x plus 7. And if you use distributive property, that gives you 2x squared plus 14x. That's the first one. All right, now I've got to subtract that from the little rectangle. The little rectangle, to get the area for that one, you multiply those two. And x times x is just x squared. Now you can keep it like that, or you can go ahead and simplify it. If you have 2x squares, you take away one of them, you end up with 1x squared. That's the area. All right, for number 41, we're going to have to multiply and check equivalence. So let's go ahead and multiply it first. Now we're going to use a calculator to check to see if this is the right answer. X times x is x squared, negative 6x. 8 times x is 8x. And 8 times negative 6 is negative 48. And if you add these two together, you end up with x squared plus 2x minus 48. Now we're going to check it. The way you check is by putting this in y1 and putting this in y2. All right, let's go ahead and check it. Once you go to the table, you can check it out and see if they all have the same answers. If every single number is exactly the same, then yes, these are equivalent. As you can tell, they're all the same. 45, 45, 48, 48, 49, 49, 48, 48. They're all the same number, so yes, this is the right answer. Let's try it again. 2x times x is 2x squared. X times negative 4 is negative 4x. 1 times 2x is 2x. And 1 times negative 4 is negative 4. Then you just go ahead and add those two together. You end up with 2x squared minus 2x minus 4. So let's try that. Again, this goes in y2. This goes in y1. And you just check to see if they give you the same numbers on both sides. So 2x minus 4, x plus 1. And on the second side right there, you're going to put 2x squared minus 2x minus 4. Now, as long as you go to the table and they're all the same numbers, and they are, then they're the right answer. This is the correct answer. All right, here we have to factor and check. Again, this is just going backwards. All right, so let's go ahead and factor it. And I'm not going to check all of them. You know how to do that. Just put this one in y1 and the answer in y2 and then see if the numbers are the same. But in this case,